This is page 1 of your exponential functions test review. Number 1 says, a part of an exponential function is graphed below, which appears to be the range of the parts of the exponential function graphed below. So your key word here for number 1 is going to be range. So my range is going to be my y-axis. So we're only looking up and down on this y-axis. So immediately I'm looking at my answer choices and I see that only C and D have the y in the middle, which is possibly my answer. So I know I can cross out A and B because X is domain, which is incorrect. We're talking about range. So now I know that range is bottom to top. So I'm going to draw these arrows here. Bottom to top, bottom to top. So which one is correctly written? So how low does my graph go on my range? So I'm going to go down to the bottom and it stops here. It stops at 4. So that is the bottom. And then I'm going to see what is the top. So how high does it go? And it stops here at 10. So if I draw this from this point, I draw an arrow, it stops at 10. So that's going to be answer choice C. It goes from 4 to 10. Bottom is 4, top is 10. The circle, it's closed. So extra ink, extra line. And then here, no ink, no line. So C is the correct answer for number 1. Number 2, it says a population of 700 foxes is increasing by 3% each year. Write a function that can be used to determine the number of foxes, y, in this population at the end of x years. So I'm going to highlight my important parts here. So I know that this first blank is going to be the initial amount. So I'm going to write that down here. Okay, because we have to know that this is going to be the initial amount. This is also my y-intercept. So make sure that you know what number that is. So in my scenario, I start with a population of 700 foxes. So 700 is my initial. That goes here. Okay. Then in the next blank, this is my rate. So what it's going up or down by. So we're going to label that as well. This is my rate. Okay, my rate, which can be found here. It says that it's increasing by 3% each year. So remember, if it's increasing, you're going to have a 1 here. Because you always start with $1, one whole pizza, whatever the case may be. But if you're increasing, you're going to have 1 plus that 3%. So you're going to have 1.3% is going to be 0.3. So this is how you write that for your function for number 2. Number 3 says the table below gives the population of a small town recorded every 2 years over an 8-year period beginning in 2015. The data can be modeled by an exponential function. Which of the following values are the best fit initial value and common multiplier for the function of the table? So when you see the words best fit, these are keywords here. Best fit and can be modeled by. Those words tell me that I'm going to use a regression equation. So I'm going to use the regression to help me find my equation. So remember that we would do y1 tilde a times b, so we can do a parentheses a times b to the power of x, and don't forget that 1 there as well. So you have a 1 here next to y, and you have a 1 next to the x. So that's how you would type in your regression. So before we do that, we start typing in all of the values. So I'm going to pull out my calculator here for Desmos, and we're going to do plus table, and I'm going to insert all of these x values first. So 0, 2, 4, 6, 8. Then I'm going to go insert all of my y values. Make sure that you do not mess up when you are typing in your values, because then you will not get the correct answer for 0, 2, 0, 3, 6, 8, 0, 3, 3, 2, 0. Okay, so I'm just going to double check my numbers, make sure that everything looks correct, and it does. So now, once you type in all of the values, you're going to type in your regression equation for exponential. So y1, go to ABC. Here's that little squiggly line, tilde. And then we have a times b, close my parentheses, to the power of x. And then don't forget your 1. So this is what it should look like. And then don't forget you have to click log mode. So click log mode, make sure that's checked, and then what you're looking for is the a and the b value. So let's go ahead and write that here. This is going to be your a value. So my a value is 4984.17, and that's going to be right here. So if this were on a test, I would just drag and drop this right here, or a drop down menu, 4984.17. That's my a value. Then my b value goes here. So my b value is 0.950189. So it's going to be 0 point. So I can cross out this one, and it's going to be 0.95. So that's that one. And that is how we do a regression. Number 4 says, fill in the scenario that best describes the function f of x equals 325 times 0.83 to the power of x. It says a population of bacteria begins at, so the first initial amount, this is where you begin. So that's my keyword right there. It begins at 325. So my answer should be that one. 325. And it's asking if it's growing or if it's decaying. Now, how we determine that is based on the number inside the parentheses here. So anything below 1 is going to be a decay. So this is decay. It decays at what percent? So this is not the percent. I figure out the percent by subtracting from 1, because remember, we always have one whole dollar or one whole pizza. So if I have one whole pizza, I have 100% of a pizza. But now I have 0.83 of a pizza. So what did I subtract, right, to get that? So let's see. We're just going to subtract 83 from 100. So we're going to use the calculator right here. 100 minus 83 gives me 17, which means I subtracted 17%. I took away 17% per hour. So there it is, 17% per hour. Number 5 says, which statement about f of x is true? So let's type this in, because we're talking about domain and range here, so I'd rather just give y'all a visual. So we're going to type it in exactly as we see it. So f of x equals 5 times 1.89 to the power of x. So here's my visual here. Okay, let's talk about domain. It says the domain is all real numbers greater than 0. So I know how to write this. So I'm going to say it's all real numbers. We're talking about domain, so domain is x. It says greater than 0. This is the greater than sign, 0. So what that means is if we take this sign and turn it into an arrow, it's saying that it's all real numbers greater than 0. Okay, well, that would mean it'd have to start here and just go to the right of 0, but it's also less than 0 too. So my domain goes all the way to the left and it goes all the way to the right. So my domain is actually infinity to infinity, which means that my domain is all real numbers. So this can't be correct. So A is incorrect. B says the domain is all real numbers greater than or equal to 0. So this is kind of the same thing. It's saying it's greater than or equal to 0. But like we said, my domain is negative infinity to positive infinity, which means that my domain is all real numbers. So A and B are incorrect. Now let's talk about the range. This one says that the range is all real numbers greater than 0. Okay, so my range is the y. So all real numbers greater than 0. This one's all real numbers greater than or equal to 0. So slight difference here. Okay, so let's see. So that means that my range, because we're looking bottom to top, that this is everything greater than 0, which is correct. It stops at the bottom at 0 and it goes up above 0. So it is greater than 0. That's correct. But is it equal to 0? That would mean it has to touch 0. Does my line here ever touch 0? Let's see. We're going to zoom in. No, it does not. My line will never touch 0. So it can't be equal to 0, but it is greater than 0. So my answer is going to be C. Remember that horizontal asymptote. That line will never touch. Number 6 says the table to the right represents some points on an exponential function. Which of the following calculations can be used to determine the decay factor in the equation? So when we are trying to determine the decay factor, so what are we multiplying by? That's the decay factor. How can I figure that out? Well, normally we take that second number and we divide it by that first number. So if I do that by setting it up, I would have 291.6 and divided by the top number, 270. So do we see any answer choices that look like that? Yeah, answer choice C. Number 7 says Riley purchased a new truck for $48,000. Each year the value of the truck decreases by 8%. Write a function that can be used to model the value of the car after X years. So remember that this first value here, the first number here is going to be your initial value. So the initial value is the new truck that Riley bought for $48,000. So that is going to be your first number, $48,000. Okay, then the next part is going to be your rate. So what it increases or decreases by. And in this case, it decreases by 8%. But that's not what goes here. Remember, you have a 100% of a pizza. So you have 100% of a pizza. If you take away 8% of the pizza, how much do you have? So we're going to do in our calculator 100 minus 8. I would have 92% of the pizza. So how do you write 92% in decimal form? It's going to be 0. So when you decrease, it's going to be 0.92. So remember, decrease is 0. And if you look at number 2, increase is always going to be 1. Last question, number 8. What is the equation of the asymptote of the graph of the function f of x? So we're just going to go ahead and type this into Desmos to give us a visual. So we have f of x equals 4.5 times 1.6 to the power of x. So I'm going to press home, and here's my picture of my graph. Remember your asymptote, because that's a key word here. Your asymptote is where the line starts to go flat. So it looks like this, starts to go flat, and it looks like it touches but never touches. So let's look here at our graph again. So where does it start to go flat? Okay, well, it doesn't go flat here, but it starts to go flat here. Okay, and here it's making this kind of line. That line is called horizontal. So the H for horizontal looks like that. How do you write the equation for this kind of line? Remember HOY, so H-O-Y. The Y stands for the equation, so Y equals. That's how we write the equation for this kind of line. So Y equals, well, where does it start to go flat at? Okay, where is this on my graph? This is at 0. It goes flat at 0. So Y equals 0 is my asymptote, because remember the asymptote never touches. So if I zoom in, notice that it doesn't touch. It looks like it touches, but it never does. So that is my answer for number 8.